Hey, it's Mrs. Golding. I have noticed that the multiplying polynomials part of your Delta Math assignment, it takes a big jump from what we did in the homework in the what's it called in the notebook. And so I'm gonna kind of give you some examples to help you. So and I know this is difficult because we're not together. So I'm going to do these in red. So, okay, so I'm going to start by just multiplying monomial times a monomial. So 3x to the 6th and 5x squared. Now this is like what's in your notebook. And so as we discussed, you're going to look and see if there are any coefficients, and you're simply going to multiply those, okay? You're going to have to remember this rule for all of this, though. This is the product rule with exponents. If you have an exponent a, a base of x raised to the a, and you're going to multiply that times that same base to a different power, you're going to just add those powers. So a plus b. This is called the product rule. Okay, let me write that down for you. It's very important. That's the most simplified of the rule so that you can apply that to all of these. Okay, so multiply the coefficients and then apply the product rule. So x and x, they have the same base. So I like to just write the base. And then I'm going to look at the powers. I'm just going to simply add those powers because they have the same base. I'm going to go back to that product rule and I'm going to add those powers. It's as if I had 6 of these, x times x, 3, 4, 5, 6, and we're going to multiply that times 2 more, right? And so that's a total of 8. That's where that 8 is coming from. Okay, so let's apply that here. The coefficients, -6. So half of -6, that's -3. And then I like to just write my bases. Okay, I have a base of A and a base of B. Okay, there's no other bases over here. And so like bases, so A and A, let's look. This A has a coefficient of 1, and the B has a coefficient, sorry, I should not say coefficient, exponent. Exponent of 1 and an exponent of 1 here, okay? So we're just going to add 2 plus 1 is 3, and 1 plus 1 is 2. So this is my answer, -3a to the third b squared, okay? So then let's do this one. This is actually a monomial, -4, monomial rs squared, monomial -5r to the 4th s. So there's 3, okay? So we're going to take -4, and we can multiply that by -5. This is going to be a positive 20. And then let's just write our bases. We have r and we have s. So this r is to the first power. This s is to the first power. If you want to put those in, it's helpful. So r to the 1 plus 4 is 5. And s to the 2 plus 1 is 3. Okay, easy peasy. Now, let's look at the next one here. So I wrote some examples here. This is multiplying a monomial by a binomial. And so what we're going to do is we're going to remember 2 things. We're going to remember the product rule, okay, which we just talked about, and the distributive property, okay, of multiplication. So those are the 2 things that are going to help us accomplish this. So 3x squared. So we have a coefficient of 3 and a coefficient here of 2, just of that term. Let's distribute here, okay? So 3 times 2 is 6. And then x and x, right? Those they share a base. And so this is to the first. We can take the 2. So again, I'm distributing that part also. So 2 plus 1 is 3. So 3x squared times 2x is 6x to the third. Now, the next part, I'm going to do a different color. So I'm going to take my 3x squared, and I'm going to take my 3 this time times a negative 5. Okay, so that becomes negative 15. Now my x squared that's right here, there's no other x, but I can't lose him. He's still a part of all of this, but he's just an x squared. Okay, so he's just coming back along with the party. Okay, so that's my final answer for that one. Okay, let's look at this next one. And I do agree these are challenging, guys. So give yourself a chance to figure these out. Okay, so we're going to distribute 5x y to the third times this binomial, 3x squared y plus 7x. Okay, so we have a coefficient and a coefficient, and we have another coefficient over here. But let's just take these first two. I'm actually going to undo that last thing. Okay, so we're just going to focus on this times this. I'm going to go upside down since I don't have room. So 5 times 3 is 15. I have an x and I have a y. So now let's look at the powers. X to the first. So 1 plus the 2 makes a 3. And then 3 plus another 1 makes a 4. Now, in a different color, I've got my same 5. This time we're going to multiply it by 7. So 5 times a positive 7 is a positive 35. And then I have x, and I still have a y, right? Even though it's not there twice, it's still a part of all of this. So I have x to the first times x to the first. So that's going to be x to the 1 plus 1, which is 2. And then y to the third, and there's nothing over here, but we're just going to keep that y to the third, okay? That's another pretty challenging example. Okay, so hold on to your seats. Let's go to the next one. So we're going to now multiply a monomial, which is this 3m to the third, times this trinomial, okay? So we're taking another step forward. Let's go back to red here. So coefficient, 3 times 2. We have 6, and then we have an m, and that's the only variable we have, okay? So m, and then we're going to add the 3 plus 3 and get 6. And then I have, for the next one, I have 3 times a positive 6, so that's a positive 18. I still have an m. This time I have a 3 plus a 2, which is, nope. I just said that out loud, didn't I? 3 plus 2 is 5. There we go. And let's do a third color. I like that green, by the way. We're going to multiply. So we're using the distributive property and we're using the product rule. So 3 times a coefficient of 1, and that's a positive 1, so that's a positive 3. And then m, and this is to the first and to the third. So 3 plus 1 is 4. Okay, so now I have multiplied that. Let's go to this next one. Okay, we're going to multiply a binomial and a binomial. I'm going to show you several ways to do this in class, but for right now, I'm going to talk about it just using the distributive property. Okay, in class, we're going to use some manipulatives and we're going to use another area model. But for right now, just to build on what we've been doing, I'm going to go ahead and show it like this. So what we're going to use is the distributive property. Okay, distributive property. Distributive property. Okay, and we're also going to be using that product rule. Okay, so that product rule and the distributive property, they apply to all of these. okay? So it's really not like use this trick for this one, and for these, use this trick. You might hear some teachers, when they're teaching this, use a word called FOIL. And I'll explain why they're using that, but I want you to understand that we're talking about the distributive property and the product rule. Okay, so this is x to the first and x to the first, right? So we're going to write that. There's no coefficient, so that's something we don't have to worry about. So x to the first times x to the first is x to the 1 plus 1, which is 2. Now, I have to distribute this x also to this 5, okay? So we're going to do x times 5 times a positive 5 is a positive 5x. And then I'm going to come to the other part of this binomial, this constant 1. We're going to multiply this times both of the terms in the binomial that's next to it. So 1 times x, a positive 1 times x is a plus 1x. And then a positive 1 times a positive 5 is a plus 5. Now, the thing that we're going to do here is we're going to notice that when we do this, we end up with 2 like terms in the middle. So we're going to combine those like terms for our final answer. Wonder what other colors I can get. Let's try this one. So we end up with x squared plus 5x plus 1x is 6x. Remember, it's don't do something weird though. Don't do like 5x squared there. You're not multiplying them. You're combining them with addition, okay? So then you have to kind of go back to your adding and subtracting rules. Just combine like terms. I'm going to write that right here. So this one, combine like terms. And then plus 5, okay? So that's the final answer for that one. So let's go ahead and do the same thing for this one. And I know I mentioned I would do this in class. Let's just go ahead and do it right here. So x plus 6 and x minus 2. I am going to write this as an area model, okay? So we talk about area, that's just multiplying, right? To find the area of rectangle, length times width. So we're going to take advantage of that. We've seen this in other areas that I've shown you throughout the year, but let's go ahead and try it here. So this is another way of looking at it. So we have x times x, okay? I'm going to do this in another color. That's x squared. And x times a positive 6 is a 6x. And an x times a negative 2 is a negative 2x. And a negative 2 times a positive 6 is a negative 12. Now, the nice thing about this model is when you put these in, you're going to be able to see those like terms, just like you did before. And those like terms are located right here. So our final answer is going to, and we're going to put these in standard form. So descending order of degree. And we talked about what that degree is. So the highest degree here, the highest exponent is 2. So it's a quadratic polynomial. So x squared, and then we have negative 2x plus 6x. That's a positive 4x. And then we have a minus 12. So we have multiplied those two binomials. And the interesting thing you might notice is that when you multiply binomials, you get a trinomial. 2 multiplying binomials, you get a trinomial. Look back here. When you multiply a monomial times a trinomial, you get a trinomial. When you multiply this monomial by a binomial, you're going to get a binomial and a binomial. So this point right here is where it starts to change a little bit. So a binomial times a binomial gives you a trinomial. Okay. I'm going to go ahead and do this one using that distributive property. And so let's try the red again. Okay. Again, I'm going to show these in different ways. You'll probably latch on to one of them. more so than another. So x to the first times x to the first is x to the second. We're going to take that x term times the negative 7 now. So x times negative 7 is negative 7x. And I do want you to, I know that that's also x times negative 7. Think of it with that coefficient, like, so you kind of switch the order. Does that make sense? The commutative property says I could write that as minus, so what would that be? Plus x times negative 7. Don't do that. That's going to get weird. So then let's multiply these. Sorry, that was supposed to be a different color. So negative 3 times x is minus 3x. And then a negative 3 times a negative 7 is a positive 21. Okay, so we have a final answer here, x squared, and we're going to combine like terms, right? We have a negative 7x and a negative 3x. So we have a negative 10x. Don't square it. That's a common mistake. Just combine like terms and keep it like it is. And then plus 21. So I want you to notice the signs when I have a positive. Let's use green. I have a positive binomial, so a positive positive. We end up with two positives in our trinomial. When I have a positive times a negative right here, we end up with a positive and a negative. And when I have a negative, negative, we end up with negative, positive. Okay, that'll be important down the road. All right, so let's go down here. All right, this is what I believe is in your Delta Math assignment. And I think that's kind of a dirty trick on my part. I just sometimes it's good to throw things out there that might be a little challenging and see what happens. So that's what we did. If it fell apart, it's okay. You know we're good. We can roll with it. So I believe that when I looked at the Delta Math assignment, the explanation actually gives it as an area model. So I'm going to show this one as an area model, and I'm going to show it like this. So usually when it does the area model, it looks something like this. So that's the x and that's the minus 1. We're going to take both of those terms times the 3 terms of this trinomial. So x squared, and let's leave those like x squared. And then I have a positive 2x and a positive 3. Okay? And if you want to, you can put those little positives, right? You don't have to. So then let's do this in blue here. So the area model says we're going to take each box and find its area. So x times x squared. That's x to the first. So that becomes x to the 2 plus 1 is 3. And then I have coefficient of 2 and a coefficient of 1. So 2 times 1 is 2. And then x to the 1, x to the 1 becomes x to the second. That's the product rule. Okay. And then we have 3 times x, which is 3x. All right. We're going to find the area of this box right down here. Okay. So x squared times negative 1. That's negative 1x squared. Okay. So negative 1 times a positive 2x is a negative 2x. And a negative 1 times a positive 3 is a negative 3. So I've filled in my boxes. Now I go back and I look to see if I can combine any like terms. And they're going to be diagonal like it was for the binomials. So we have these like terms. And then I have these like terms. Okay. So we're going to go ahead and write this. And I'm going to write this answer in black. So we have the x to the third. All right. Gotta have him. Now we have negative 1x. And then we have plus 2x. So negative 1 plus 2. That's just a 1. And it's positive, right? So that's a plus 1x squared. And then we have a negative 2x plus a 3x. That's a plus x, right? Plus 1x. And then we have minus 3. So a binomial times a trinomial gives me a quadnomial, or a 4-termed polynomial. Okay? All right, so let's go to the next one. Again, this is in standard form because it's in descending order by degree. 3, 2, 1, 0. Nope, not 0. Not 0. Don't ever think that. That's a big mistake. Anything to the power of 0 is 1. Sorry, 1. That's 1. Okay, let's go down here. These are the problems that are in your Delta Math. So I pulled this one right out of there. So let's just try it. Again, if you're messing up on these, it's okay. I did give you quite a challenge, and that's not always a bad thing, right? Not always a bad thing. Let's try this. So 3x. I'm going to show this one without the area model. I'm just going to use the distributive property, which is what the area model does. It just organizes it differently. I'm just going to show this one like this. So we need to multiply every part of this binomial times every term in this binomial times every term in this trinomial. So we're going to start with 3x times 3x squared. 3 times 3, the coefficients are 9. And then x to the first times x to the second is x to the 2 plus 1, which is 3. And then I'm going to do the 3x times the x, and that becomes a positive 3x to the 1. X to the 1 becomes x to the 2. And then I have a 3x times a constant of 4. So 3 times 4 is 12, and I still retain that x. Okay, he doesn't just fall away. Next, okay, I'm going to multiply the 2, constant of 2, times every part of this trinomial. All right, so 2 times 3, the coefficient of 2 and 3, that's a positive 6x squared. He does not fall out. He's still important. Now, 2 times x, a positive x. So a positive 2 times a positive x is a positive 2x. And then a positive 2 times a positive 4 is a positive 8. Once you have this written, then you're going to go back to your rules of adding and subtracting with monomials, because we have 1, 2, 3, 4, 5, 6 monomials. There's 6 terms here, and we're going to combine like terms. So combine like terms. Okay, so the like terms, what do we have? 3x squared. I'm going to grab the positive sign that goes with it, and a positive 6x squared. And then I have a positive 12x and a positive 2x. Okay, so don't get confused. You're not multiplying anymore. You're combining like terms, which is addition. Okay, so let's go ahead and start with the terms that don't have any like terms. So we're going to bring down the 9x to the third. And we're going to do this so that we maintain standard form, which is descending order of degree. So that's to the third power. Let's work with the exponent of 2. So we have a positive 3x squared plus a 6x squared. 3 plus 6 is 9. X squared. Remember, when you're combining like terms, don't mess with the exponents anymore. Don't add them or anything. And then we have a 12x, a positive 12x plus a positive 2x. That's a positive 14x. Don't mess with that x. Don't make it x squared. Don't do it, okay? And then we have a constant of 8. Now we have we've created our answer in standard form. It's a polynomial in standard form because it's in descending order of degree. 3, 2, 1, 1. Okay, and the constant is last. I believe I might have put one more on here. I know this video is getting long. Hopefully you're fast forwarding if you need to. All right, so let's go ahead and I'm going to use this method here, the distributive property. Again, that area model is very helpful to some people. So I'm going to let you use that if you need to, of course. So x times x squared, I'm going to do this one a little faster, x to the third. And then a negative 5x times x is a minus 5x squared, because there's a first power here. And then 6 times x is a positive 6x. And then I have x times x squared is a positive x to the third. And then x times a negative 5x is a negative 5x squared. And an x times 6 is a positive 6x. We're going to combine like terms. I have x to the third and a positive x to the third. I have a negative 5x squared and a negative 5x squared. And I have a 6x, a positive 6x, and a positive 6x. Okay, so I'm going to go ahead and look at all my terms, and let's go in descending order. So this is a 1x to the third, or cubed, 1x cubed. That is 2x cubed. And then negative 5x squared plus a negative 5x squared is a negative 10x squared. And again, when you get these big ones, if you need to cross them out as you go, right? So that you remember what you did. And then 6x, so a positive 6x and a positive 6x is a positive 12x. Cross them out and you're done. This is in descending order to polynomial, to trinomial, to the third degree, a leading coefficient of 2. It has other coefficients of negative 10 and of 12. It has variables of x, and you guys are amazing. Have a great day.